Hello, here we are again with another series of videos for Mathematics Grade 10, and for this three-part lesson video, we're going to discuss about statistics and probability, specifically permutation and combination. And you are still with me, Teacher Ybeth, or Ma'am Dusal, or Ma'am Alpuerto. Again, don't forget to subscribe to my YouTube channel and hit that notification bell to be updated with the lesson videos that I'm going to upload. So for this first part of lesson video, let's have first the fundamental principle of counting. So in the question, if do you know how to count, most of our answers, or of course our answer is yes. But don't you know that there are three counting techniques that we may study with? And for probability statistics, we will be focusing on outcomes or possibilities or ways. So let's focus our attention on counting to get the possible outcomes, possibilities, or ways. So let's discuss one by one the different counting techniques. Let's start with the table of values. Now, the table of values is also called the grid table or the product table. So, let's have this example. Find the number of outcomes in tossing a coin twice. When we toss a coin, there are only two possible outcomes, the head and the tail. So, using this table, let's tabulate. So in the first toss, it could be a head or a tail. In the second toss, the same. It could be a head or the tail. The intersection between the first and the second toss is the possible outcome, or the number of possible outcomes. So if first is head and second is head, so we have a head and a head. If first is a tail and the second is head, a tail and a head. If the first toss is head and the second toss is tail, we have a head and a tail. But if the first toss is a tail and in the second toss it's still a tail, we have a tail and a tail. So there are how many possible outcomes? When you toss a coin twice, so there are 4 possible outcomes. Again, it could be a head and a head, or a tail and a head and a tail, or tail and tail. So this is the first counting technique, which is using the table of values. Let's proceed to the second counting technique. We have a tree diagram. So we're going to prepare a diagram in finding out the number of possible outcomes or ways that an event or as an event unfolds. The tree diagram is used when the number of possibilities is not that large, or it can also be used for events that do not affect the outcome of each other. For example, student X has to choose among 2 courses of study, which is science and math. And then he also intends to enroll in one of the top 3 universities of the Philippines, namely University of the Philippines, or UP, De La Salle University, or DLSU, and University of Bohol, or UB. The same here, the student X could take math, enrolling in UP, De La Salle University, or UB. So we have science, UP, science, De La Salle University, or science, UB. We have math, UP, Math, De La Salle University, or Math, University of Bohol. So counting the number of possible outcomes, we have 1, 2, 3, 4, 5, 6. So there are 6 possible outcomes or ways basing on the given example. So this is called a tree diagram because it looks like a tree with branches. So this is the second counting technique. Let's proceed to the third. The third one is systematic listing. From the name itself, systematic meaning there's a system, and listing meaning we have to come up with a list. Again, this one involves coming up with an actual list of all possible outcomes. And it is used only when the list is just a short list. For example here, how many 3-digit even numbers can be formed using the digits 0, 1, 2, 3? Sometimes this is applicable when making a code. So we have to choose among digits available. So here, we have to make 3-digit even numbers. So the first digit cannot be 0. So for the first digit, our choices are 1, 2, and 3. Because we cannot choose 0. In the second digit, we could have 0, 1, 2, 3. The same first digit. Same here. 0, 1, 2, 3. Same here. 0, 1, 2, 3. And there are 2 choices that we can use as our last digit, since it talks about even numbers, or the digits should be even numbers. So we have only 0 and 2. So even numbers should end with 0 or 2. So we have 0, 0, 0, and 0. And another round, the same first and 2 digits, but the last digit is 2. The same here. Another round. Okay, we have already the list of possible 3-digit even numbers from the digits 0, 1, 2, and 3. So there are 24 possible ways or possible numbers. Right? We call this as a systematic listing because it is a list or a systematic list of possible outcomes. Alright? Next, we have the fundamental principle of counting. Summing up, the 3 counting techniques is what we call the fundamental principle of counting. Let me correct that this is not PFC but FPC, fundamental principle of counting. It says that if one event can occur in M ways and another event can occur in N ways, these events can occur in Mn ways, provided that the 2 events are independent events. Now, please take note that M and N are variables. They represent any possible number. When we have Mn, the operation involved here is multiplication. So let's discuss further using the example here. So the two-digit numbers are formed from digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Letter A. How many two-digit numbers can we form? So M here and N represents the choices or the possible numbers or possible objects. So first, how many two-digit numbers can be formed? Take note here that we have 10 digits to choose from. For letter A, of course, we cannot have 0 as our first digit. Therefore, the choices or the M is 9. And our N or the second digit is 10 because we can now have 0 as our second digit. We are only asked to form two-digit numbers. We have MN or 9 times 10 is 90. So from the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, it is possible to form 90 two-digit numbers. Okay, there are no restrictions. In letter B, there is a restriction. It says how many are even. So the same thing, the first digit has 9 choices. The second digit, or for even numbers, or for a number to be even, it should end with 0, 2, 4, 6, and 8. So there are 5 choices. So 9 times 5 is 45. So there are 45 even numbers. For letter C, how many are odd? So the same, 9 choices for first digit. And for a number to be odd, it should end with 1, 3, 5, 7, and 9. So the same number of choices, which is 5. 9 times 5 is 45. Even without computing for letter C, we can identify that out of 90 two-digit numbers, if there are 45 even numbers, it's obviously that 45 are odd because only 45 is left. So this is the application or the discussion or the explanation of the fundamental principle of counting. Alright? I hope you are learning, and don't forget to proceed with the second part for permutation and combination in the main topic, which is probability and statistics. I'll see you.